Welcome back. Here's the second page of that review packet. Let's unpack that second page. All right, so here, if you'll notice, you haven't seen this for a while. We were still in school when we went over this. So this is perhaps a little bit something that you remember that well. So let's look and see what we've got here. We have this length is 2. And you know, it doesn't like that when I do that with my pen. Let's see if it lets me do it here with that. It should. All right. So we got this length 2. It still doesn't like it. There we go. And this one, 3.5. From D to C, and from A to D is 2. So this should be using corollary 1 and 2 of theorem 49. So what is that? Let's back up one. You're getting a little ahead of myself. That's where the one that states that the altitude to the hypotenuse of a right triangle, this is the hypotenuse of the big right triangle, is the geometric mean, meaning it occupies these two places in the proportion, between the two segments it splits the hypotenuse into, the 2 and the 3.5. So that's how we know to set that up that way. The altitude to the hypotenuse in a right triangle is the geometric mean of the two segments that it splits the hypotenuse into. So now we just solve that proportion. 2 times 3.5 is 7. X times x is x squared. And to undo squaring, we square root. And so that's 2.6. All right, so we found x. And we're finding these in alphabetical order. So now we find y. And there's any number of ways you can find y. Some of you will notice that here's 2.6, here's 2. This small right triangle, I could use Pythagorean theorem. Since this is meant to demonstrate these two corollaries of theorem 49, I'm not using that. I'm using the corollary 2, which is that the leg of the right triangle is the geometric mean between the hypotenuse and its projection on the hypotenuse. So for y, the projection would be this one. It's the distance from the end of this side to the altitude here. So 2 over 5.5, 5.5 because it is the hypotenuse, 2 plus 3.5. Okay, so cross multiply again. 2 times 5.5 is 11, y times y is y squared. So now it looks just like the one we just did previously. 3.3 square root of 11. Now, one thing you're going to find as we go through this packet is that you're going to get to a point where you're going to have all kinds of different tools you could use. We're going to find z next, and some of you are going to say, oh, to find z, I can use Pythagorean theorem. I got 3.5 and 2.6. Yes, you can. But as I said, since we're trying to demonstrate corollary 1 and 2 of theorem 49, we're going to do something different. Let's change colors here. All right. So I'm going to use the same thing I just used. So this is the leg of the hypotenuse of the big right triangle. This is its shadow on the hypotenuse from the end of the side here to the altitude. So the leg of a right triangle is the geometric mean. Remember, that means it occupies these two places in a proportion between the hypotenuse and the projection on the hypotenuse, which is the 3.5. So multiplying that out, I believe that says 19.25, and the square root of that is 4.4. And there you have it. That's corollary 1 and 2 of theorem 49. That's number 4. Number 5 involves a little bit less labor here. So let's look and see at, here's a right triangle. What are the 3 pieces of information? We have 2 knowns and an unknown. The 2 knowns are this angle measure and the side opposite that angle. The unknown is the other side. The two legs of the right triangle are involved here, not the hypotenuse. So that should tell us right away, okay, we have a tangent ratio need here because tangent involves the legs. Remember SOHCAHTOA, tangent, opposite over adjacent. So there you go. Tangent of 57 equals 23 over x. So we have to multiply by x, and that's how we get down to this, what's in blue, x times the tangent of 57 equals 23. So this is our variable, so it's x times, so we're going to undo it with division. 23 divided by the tangent of 57 is about 14.9. Let's examine how we get that. So going back to the calculator, if you don't mind. Okay, so we did 23 divided by the tangent of 7. So 23 divided by the tangent of 57. You can see it's 14.9, just as we've got here. Okay, on to the next one. Number 6. Okay, here now we're stuck again having to find 3 different variables. So let's change colors again and find them in alphabetical order. So X, Y, and Z. Okay, so what should we use? Let's forget about the Y and Z for right now because we're trying to find X. So what are our 3 pieces of information? Our 2 knowns are the legs of the right triangle. That means tangent. Our unknown is the angles. Since our unknown is the angle, we're going to use the inverse tangent. So it'll set up like this. And it says it equals 57 degrees. Check that. Okay. So inverse tangent, and it's, let's see, it was 3.2 over 2.1. So 3.2 divided by 2.1. And as you can see, it's 56.7, which is drawn to 57, just as we've got here. All right. And you're kind of getting a sneak preview of what comes next. Obviously, we can use what we know about triangle angles. So 180 minus 90 minus 57 is 33. So we found y rather easily. Z, how will we find z? Well, you got a lot of options here. You got sine, cosine, and I believe that I used for this Pythagorean theorem because I haven't used it yet in this one. 2.1 squared is 4.41. 3.2 squared is 10.24. So that makes 14.65. So c squared equals 14.65. So we can square root that and get that it's 3.8 centimeters. All right, and then we've got this one here, number 7. And again, we got to find x, y, and z. So here's x. All right, and what, forget about y and z for right now. We have 3 pieces of information, 2 known and 1 unknown. What do we know? We know 2 side lengths. One of them is hypotenuse. That means sine or cosine. The other one's the opposite leg from the angle we're trying to find. That's 50. So opposite over hypotenuse is sine. So we're going to use the inverse sine and figure out what x equals. So that would be inverse sine 50. So let's go ahead and hit the calculator up and see what that is. Clear this out. Get our information over here so we can see what we had. Whoa, wasn't the plan. Went too far with it. All right, so we had second, or I keep saying that because all the calculators I've used in the past, you had to hit second first before you could use that inverse sine. 50 divided by 6.3. Harder to change as you get older. You'll see that as you age. All right, 63 degrees. So then we can figure out 180 minus 90 minus 63 equals 27. So there's two angles right there. All right, so let's go back to the PowerPoint. And so we have 63, 27. Now I'm finding side Z. Again, you could use Pythagorean theorem, to the side lengths. I chose to use cosine here. All right, so that meant that I was using the 63-degree angle. I could have done sine of 27 equals Z over 56.3. I chose cosine, and that's a thing. We have so much information now that we have lots of different tools. We know 5 of the 6 pieces of this. We know all the angles, and we know 2 of the sides. That gives us a lot of options. Pythagorean theorem, sine, cosine. I'm using cosine. Cosine is 63, as you can see, Z over 56.3. So we multiply both sides by 56.3. That's this. Let's go back to the calculator and see what we get. So let's clear that out. 56.3 times the cosine of 63. And it's 25.5, 25.55, which rounds to 25.6. So there you have that. You figured out every single piece, all 6 pieces of information, the 3 sides, 3 angles for this problem. All right, that brings you to the end of the second page. Hope that went well for you. And I will see you on the last page shortly.